So we're finally to solving systems of equations using all of the things that we've learned up to this point. Our first method that we will use to solve the system of equations is substitution. And with substitution, you solve for one variable in one equation, substitute that into the other equation, solve for one variable, and then what I call back substitute into either equation what you solve for, and then simplify to solve for the other variable. Now you can choose either variable in either equation to solve for, and you'll still get the same solution if you do everything correctly. There's sometimes ways to recognize if one variable in one equation is easier to solve for than others. In this case, for instance, if you look at the first equation, negative 2x plus y equals negative 11. If I solve for y, I just add 2x to both sides. And that gives me, it solves for y, gives me an expression of x that y equals that uses no fractions, and the coefficient on x is positive. So I like all those things, so I'm going to choose that one to solve for y. So write out the equation, negative 2x plus y equals negative 11, and add 2x to both sides, and we get y equals 2x minus 11. So our second step is we substitute our result from step 1 into the other equation. So with our first equation, we solved for y and got y equals 2x minus 11. Now we substitute that into x plus 3y equals 9. So x plus 3 times, we solve for y as 2x minus 11 equals 9. And then step 3, simplify and solve, in this case for x, but whatever variable that we solved for and then substituted. So x plus, distribute the 3, we get 6x minus 33 equals 9. Add 33 to both sides and combine like terms, and we get 7x equals 9 plus, write this a little clearer, 9 plus 33. So 33 plus 9 is 42. Divide both sides by 7, and we get x equals 6. Alright, so I'm going to go over here to the other side of our screen. And with step 4, it's substitute our solution from step 3 into either of the original equations. I'm going to go ahead and substitute into both equations just to verify that x works. That we'll get the same y value if we use x equals 6 for both of the equations. So negative 2, we'll use our first equation first. Negative 2 times x equals 6 plus y equals negative 11. So negative 12 plus y equals negative 11, and adding 12 to both sides, I get y equals 1. So let's just check to verify by substituting into the other equation. Again, x equals 6, so this second equation would be 6 plus 3y equals 9. Subtract 6 from both sides, 3y equals 3, and y does indeed equal 1, substituting into the other equation as well. And then step 5 is simply the solution, which we write as an ordered pair. So x equals 6 and y equals 1. That gives us the ordered pair 6, 1. And then finally, to check, you can graph, just as we've shown how to graph systems of equations in the past. Or, what I'm going to do, we can substitute the ordered pair into both equations to verify that they make true statements. So -2, substituting into our first equation here, -2x plus y equals -11. -2 times 6 plus 1. Let me go back here, and my color coding is getting a little off. -2 times 6 plus y is 1. We want to know, does that equal -11? So -2 times 6 is -12 plus 1. -11 equals -11, so that it checks in the first equation. Now let's use our second equation. X plus 3y equals 9. So 6 plus 3 times y is 1. Does that equal 9? 6 plus 3, does that equal 9? And of course 9 equals 9, so it checks in our second equation as well. So our solution to the system of equations, -2x plus y equals -11, and x plus 3y equals 9, is 6, 1. And we get there using substitution by solving for one variable in one equation first, then substituting that result, whatever variable we solve for in terms of the other, into the other equation, then solving for the variable that we're left with in our expression after we substitute, and then substituting the solution from that step for the first variable into either equation, or I like to use both just to make sure I'm not making any mistakes, to solve for the other variable. And then we check by putting our coordinates from our ordered pair into both equations to verify that they make true statements. And that's how you solve a system of equations by substitution.